All right, hello there everyone. Good morning for those of you online, good day, good evening. Thanks for joining us here today. My name is John Link. I'm the Partner Product Manager for Microsoft Discovery. I'm going to be joined by a couple of friends today who will introduce themselves as they come on, but we've got a lot to share with you, so I'm going to jump right into it here. I'm going to kind of speed date you through the Microsoft Discovery platform. For those of you who don't know what we're doing and what we've got, I want to make sure you're grounded in that, but we're going to very quickly move on to what our partners at Syensqo have done with us here and what some of our other teams at Microsoft have used this platform to deliver real results. Like for me, this is the excitement, is showing what you can do with these solutions, and that's where we want to spend most of our time today. So, the Microsoft Discovery platform. You know, we're at an exciting time in the world today with all of these technologies that you've heard a lot about this week shaping the future of R&D. So how can we use these technologies to drive real outcomes? That's what we think about in our team a lot. You've also heard a lot this week about agents. And for us, we think about how we can best apply these agents to make progress on high-value scenarios. And for us, in all of these areas, with the world of AI and all the advances there, the high-performance computing that we have in Azure, the advances we're making in quantum, and the world of robotics coming into play, you know, for us, how we apply these is all grounded in something that honestly most of us learned back in primary school, and that's the scientific method. We see an amazing opportunity here. In this new world, people and specialized AI agents can cooperatively refine knowledge and experimentation in real time in a continuous cycle of discovery while still maintaining the control, transparency, and trust required to do real science. Together, people and agents are going to be able to reason when presented with complex knowledge, specialize in distinct tasks, and learn from actual scientific results. This discovery loop, you know, mimics that scientific cycle, and we're able to bring all of these latest advances in technology to the hardest problems that our planet faces. And at Microsoft, we want to amplify the ingenuity of scientists to be able to usher in a new era of accelerated discovery for empowering research and development teams with access to all of these emerging technologies. But, you know, we've learned that there are challenges to doing this well. A lot of these generic solutions for AI are not well suited for R&D. There's unique challenges to the disparate, broad, and often conflicting world of scientific data. In many of these domains, you need very specialized AI to be competitive. Another big thing we see is that, you know, there are a lot of great advances, new models, new technologies out there, but these are often bespoke point solutions that can't really apply across a whole end-to-end workflow and are often very complex for your normal R&D team just to launch on their own. And again, here at Microsoft, we hear a lot from our customers that trust, compliance are non-negotiable. This is something that when we're looking to put together a product or a platform, we know these are table stakes for us. Which is why we announced Microsoft Discovery. We announced this platform back at Build. And for us, you know, we saw that solving these complex problems demanded a whole new paradigm, one that isn't just aimed at doing the same experiments faster, but changing the way that we approach R&D. And that's why we announced this new enterprise agentic platform that aims to accelerate this process. With Microsoft Discovery, we are bringing agentic R&D to life by leveraging the latest innovations from Microsoft and the broader scientific ecosystem. So what does that mean in practice? We're going to click through some of the main pillars of what was critical for us, and we're going to start with what we call the discovery engine. If we think about what we've seen just in the past couple of years here with the world of agentic AI, you know, we've seen this evolution going from single agents for single user, just doing one task, to multi-agent systems working for that user, to orchestrate and answer questions, and to the world that many of us live in today, this multi-agent, multi-user world, where really teams of humans and agents can collaborate for complex problems over time. So for us, the question was, how do we best apply this thinking to research? And again, grounded in the way that scientists and researchers think, back to that scientific discovery cycle. Which is what led us to develop what we call the discovery engine. And this is the core cognitive brain behind the Microsoft Discovery Platform. And this is the tool, the layer that we use to reduce days of work down to hours. All starting with a task planning layer that manages all of these complex tasks that can be assigned to agents, to human users, really break down these complex problems. And as we know, these breakdowns aren't one-time events. You learn things in any scientific experiment. You'll branch out. You'll get to dead ends. You'll need to come back. We need a system that manages that, both from the thinking through the problem alongside the scientist, but also being able to capture all of that web of knowledge and interaction. And then ultimately, executing on those tasks. It's not enough just to go do something. You need to be able to use the tools. You need to be able to use multiple models. It's not about a one-model solution in today's world. We need to look at the best-of-breed models that are out there. We need to compete them against each other. We need to aggregate, in some cases, results from 2 different models. And we need to coordinate that whole process and feed it back into the learnings of this discovery cycle. And in the end, agents are only as good as the tools you give them, which is where we come to our science catalog, which is what we call the backend, where we host all of the external and internal data sources, the tools, and the specialized AI models that you've loaded up onto the platform. These are the things that matter to you as a scientist or researcher. You know for your own domain where the most valuable data lives, if that's proprietary, internal data, public data sources from valued research sites. All of these things can be pulled together into your science bookshelf, and you know the best tools and models that apply to the problems you're working on. It's not enough just to go to the latest LLM out there and say, find me the right tools or the right workflow. You need to give the guidance to really unlock the best possible solutions for the work that you're already doing. And throughout this cycle, the R&D team is always in the loop, and all of this information is fed back into a knowledge graph that is at the heart of the discovery engine. We need to know, much like a researcher does, as you run through an experiment and you find those dead ends, you find new interesting leads to follow, you need to be able to track those back. This task planner obviously can't do all the work on its own to know, have I gotten to an interesting outcome? Do I need to iterate again? We need to be able to reason over that knowledge of all of those agents working together alongside the scientists and capture that. And that knowledge graph, it isn't about a one-time operation. It isn't, what did I learn in this experiment? You want to maintain that knowledge just like you do with teams of engineers. You want to know the next time you enter into a difficult problem, what did I learn last time? What didn't work out? How can I take advantage of that to get to my next outcome faster? And that's what's at the heart of the discovery engine. Moving on from there, we said we don't want to focus on point solutions. It's not just about one amazing model that I help you with, let's say, a new lead in materials discovery. It really needs to be a comprehensive enterprise platform. And again, we think of that in the terms of this scientific discovery cycle. It all starts with knowledge and looking over these vast data sources, drawing insights, using the latest graph-based technologies to aggregate and look across these disparate data sets, generating hypotheses, leading your scientists through the work required to help come to new conclusions, to suggest new experiments. And again, you actually need to be able to use tools, run experiments. It's not enough just to propose a thought or a direction. You need to be able to execute on it. And in the end, you need to be able to learn from those results, analyze them, and iterate back around again. It's all about taking you from these narrow single-point solutions at one point in time to a real overall transformation of the way we think about doing R&D. So for us, that's why we think of this as a comprehensive platform for R&D. Across the top, you see that I've laid out some domains there. These are areas where we focus within Microsoft and with our partners because we know there's value in these areas. Myself, with my part of the team, we started looking at chemistry and material science a long time ago. We've got a lot of great partners in the life sciences and pharma space who've been using machine learning techniques for years to really advance their work, and we're partnering with them today to show that you can do even more with a full platform like this. Similarly, we've got teams working on physics and semiconductor work to show how these same broad horizontal capabilities can apply to these domains as well. Now, we have targeted efforts at Microsoft here to focus on these areas with our partners today, but we see that this platform approach can apply to many other science verticals as well. And you'll notice if we skip down to the bottom of this slide, what we call the science supercomputer down there, we're not trying to invent everything new. This is important for us in the world of how Microsoft works, that when we build this platform, we don't want to reinvent anything that folks are already using. We build on the best in Azure AI Foundry. All of the new announcements you've seen of what's available with agents this week in Foundry are things that we inherit. We don't want to make you redo great work you've done. If you've got data that you're accessing through Fabric connectors off in another cloud or somewhere else, we pull that right in the same way. What we do is that level you see in the middle there is we try to fill the gaps of what's the difference between, myself as a product owner, I don't want to just be the best system integrator in the world to pull together a bunch of great Microsoft technology. I need to do more with it. And that's what we do with that discovery engine at the heart of being able to take these technologies and really drive high-value outcomes. A Copilot for Science as a front end to help provide a natural language interface to work with for all of these capabilities. The Science Bookshelf that I referenced to apply today's best and greatest technologies across the corpus of data that you've said matters the most to you. And this ecosystem. Again, we win when we can make a broad and extensible platform. I'm not going to pretend that I am going to onboard every single new tool that is best for you in your particular domain. You're the one who knows what those are. So we want to make sure that we've built an extensible ecosystem where folks can bring in the best of their capabilities to solve the problems that matter to them. I mentioned the Copilot for Science. This is really about the front end. Any of you who saw our presentation back at Build saw how I walked through a coolant discovery project live using this Copilot front end. We've used this system to drive real-world outcomes, from developing new battery electrolyte materials to a PFAS-free data center coolant, all on our own. And this is what gets me excited is, hey, if my teams can do this kind of work with this platform, I want to give these capabilities to the whole world of researchers and scientists to see what they can do in their own individual domains. I mentioned the ecosystem. This is key for us. Like, we need to be able to manage these models, tools, and agents that are available to users on the platforms, but really we want to make this open to a broad ecosystem. Any model that you can pull up in Foundry, we can bring in and make aware to the science agents. Really gives us a lot of power. And just to make that real, I want to highlight one of our partnerships right here. Partners can easily integrate their models and tools to Microsoft Discovery to help solve their complex scientific tasks. In this case, Microsoft Discovery is acting as the platform of choice for in silico medicine's foundation model, 𝗦𝗲𝗀. So Discovery provides the infrastructure, orchestration, data integration, and user interface that's needed to unlock the full potential of 𝗦𝗲𝗀 for drug discovery. And in this case, 𝗦𝗲𝗀 leverages a large language model to process both structural and spatial data and is designed to solve hundreds of diverse tasks, providing a broad and comprehensive range of chemical knowledge. And so for us, pairing the latest and best partner offerings with Discovery enables faster, more reliable, and more explainable R&D outcomes for researchers, allowing them to move from idea to validated candidates with unprecedented speed and confidence in the end. So, this is one example, and we're very excited about all the work that we've been doing with in silico. But again, this applies to the whole ecosystem. If you've got a new and unique model, you've got an approach that you would like to try, we can bring that into the system, and the scientific discovery agents can then work with these capabilities as a new set of tools that they have for that greater R&D cycle. And a lot of that is driven by the scientific bookshelf here. This is that repository I mentioned of all the public, proprietary, or licensed knowledge that you say matters to you for the workflows that you're running. We started with GraphRAG here. And I can tell you all here, we've moved multiple iterations, of advancement in partnership with Microsoft researchers and others across our company to always stay ahead of the curve of what is the best technology on the planet today to help draw unique insights with grounded data that provides references back that can get you to the best outcomes quicker. And all of this, we know, requires a lot of compute. And so we manage our own science supercomputer here, taking those best abilities of all of the HPC scale across Azure. Future quantum computing endpoints, as they'll become available, are all exposed as callable agents to the discovery engine. So we're able to consolidate all of the knowledge and data estates, across multiple clouds, provide them access into the same instance, and then execute on demand. And in the end, we said, we can't do this unless we do it the right way. And that is about being a real enterprise solution. For us, that is about being secure. We built on Azure, developed with the full Microsoft security development lifestyle. We know how important that is for our customers. We want to be trusted by the actual users of the system. The whole interface and the way we work is designed to include the human in the loop throughout the process with transparency and enterprise governance throughout the loop. We want to help you do the important parts of the work you care about better and faster. It's not about changing what you're doing, it's changing the way you do it. And we need to be future-proof. We understand that the world here that we're in, both from AI and the models and tools that we use, are moving rapidly. So we've designed the system to really be able to scale to take advantage very quickly of the latest and greatest things that come down the road. And I mentioned those different domains that we saw across the top. These are just a few examples here. I'm not going to read this all out to you here, but really, when I say comprehensive platform, I mean it, in that we've used it, and our partners in our private preview that we're in right now have used it for many of these workflows that you see right here on screen today. And again, others is a broad bucket there. For me, that's the entire world of all the great ideas people have of the scientific challenges they want to take on, the research questions that they're thinking hard about. We're excited to have others bring those into the platform and see what they can unlock, because I think the possibilities are endless there. But, it's enough just for me to talk about what is possible here. I really want to spend some time showing what others can do with the platform. So first, I'm going to hand it off to Julie from ScienceCo here to show what they've done with the platform as one of our private preview partners. Julie, there you go.
Thank you, John. Thank you. So I'm Julie Mijajlovic. I'm the manager of the IT, R&I, Research and Innovation, R&D teams, and the program manager for discovery at ScienceCo. So ScienceCo, you may not recognize the name because we are a very new company, less than approximately 2 years old. But we have 30,000 employees, more than 60 sites all around the world. And half of the sites are in the United States here. So we have, in our research and innovation, more than 2,000 researchers that are building our products for tomorrow. And our main challenges is to make the progress. But even if we are a young company, we have deep roots. So I will show you a picture in the next slide. No, it will be the slide after. But just to tell you a bit more about the product we'll build. So if you use a shampoo or a conditioner this morning with your shower, you use ScienceCo products. If you have no hair, no problem, we are elsewhere. In the healthcare, for example, with our polymers, we fabric membranes that are used in dialysis. But globally, if it's fly, we are in it, whatever it is, the air or in the space. And if it drives, we are in it also. We are building thousands of products that are used in our daily world. So let's show me the picture I was mentioning before. This picture is, some people say that it's the most intelligent photo that has been taken, and I'm fully aligned with that. On this picture, you see the 24 highest engineer, highest brilliant scientists of the year. It was taken in 1911. It was from a Solvay conference built by our founder, Ernest Solvay. And in this picture, you may recognize some of the brilliantest people in the scientist world: Albert Einstein, Marie Curie, Max Planck, and many others. And Ernest Solvay is also in this picture, the third from the left. So Ernest decided to bring them all together in conferences to talk about and to collaborate on innovation. And all what they discussed during those conventions is they talked about what we use today. And For example, quantum, if we talk about quantum computing, you may know that it has been created by Max Planck and expanded by Einstein. And this is precisely why the Q of 𝗦𝗫𝗀𝗀𝗀 stands for quantum computing. That's this mindset and the way we collaborate also still today. We have the same mindset, collaborating all together for the innovation. But to continue progressing and to continue to innovate, now we need to focus on AI. And we are convinced in our company that AI will help us to continue to innovate. And that's why 1 year ago, we decided to create a team dedicated to AI. So the name of the team is 𝗦𝗫𝗀𝗀𝗀𝗀𝗀AI. And this team has as a mission to bring AI at every steps of the work we done. So our first product we created, named 𝗫𝗫𝗫𝗫𝗫𝗫, is our secured, internal and secured chatbot. Then just after, we created 𝗫𝗫𝗀, a tool to bring sales and to help selling more. And thanks to this tool, we already sell 140 million of new sales at 𝗫𝗫𝗀𝗀𝗀𝗀. And now, recently, we partnered with Microsoft to bring AI at the very heart of our work, to give to our researcher, directly to our researcher, AI with agents, AI agents with discovery. So discovery is for us not only a new tool or a new platform, it's a leap forward. We are really convinced that with such a tool and aligning AI, modeling, and simulation in a unique platform will help our researcher to move faster, to create faster, and to be really focused on what matters to them, science, instead of doing things that could be replaced by agents. So let me tell you a bit the story of our journey with discovery. So it started a few months ago in April. We invited Microsoft to our main research center in the US in Alpharetta, Georgia. And with one objective was to answer that question, how AI could help us to create faster. And so we put all together around the table, Microsoft, our researchers, our business, our 𝗫𝗫𝗀𝗀𝗀𝗀𝗀𝗀 team, and we discussed about use case. And we were convinced at that time that we will do it together. We will build the tools that will help our researchers to research more faster and to innovate and to create maybe new molecules and new materials. A few months later, in July, we started our project, discovery implementation project at 𝗫𝗫𝗀𝗀𝗀𝗀𝗀. And then we faced our first challenges. The first one was to find the first use case. Which use case will we use to build this tool? We needed to find a use case that will create value for 𝗫𝗫𝗀𝗀𝗀𝗀𝗀, but of course also help us to evaluate the full potential of the discovery tool. And believe me that everyone was very well motivated to bring their use case and have their use case being the first in discovery. Second challenge is, of course, the data. And in science, we have data of kinds and really various type of data. And we faced something that people were convinced that just putting AI on top of the data will work by magic. But every magic has its preparation, and we had to learn, to identify what the researcher wants to do, to understand their workflow, to understand why those data matters. And progressively, we ingested different type of data, journals, patent, receipts, a lot of kind of data, even more picture of very old lab books handwritten. And that works. And everyone, this was the starting point where everyone were convinced that data is not only a fuel for AI, but it's the foundation of discovery. Another challenge was a technical one, because we had to onboard with our IT teams that were really motivated to work on this project, but they had to validate architecture, security, a lot of challenges, but it's complex to validate something that doesn't exist very well. It's still in preview, and they had to put aside some of their normal processes. So we embraced agility at all steps to reach the goal. And here we are today, less than 3 months after, we are our first AI agents working. And we returned back 2 days ago in Alpha Beta to demonstrate to all our researchers there our first agent in action into discovery. So we developed 4 agents, and everyone was impressed, and they are very excited, and they want to touch it now, but it's still small. We are still building. It's, our expectations are high, but the project is small. But we have all together, and we have the energy of everyone to continue. And to continue the next challenges, so we are working in parallel on building the science data backbone. It's a main challenge for the science again. We need to pay attention to the data and to the various amount of data over the 160 years of the company we are working in. And we want also to align our HPC transformation project with Microsoft Discovery, so that we can, at the end, our objective is to consider that to make discovery the front end of the tools that are used by the researcher all along their research journey. One thing which is more important also in this project is that we have the full support of our management. Meaning, instead of only supporting, they also push us to accelerate, and that's something important. Because with the motivation of our researchers, the motivation of our teams, ScienceCode.ai, the partnership with Microsoft, and the support of our management, we are at the start of something very powerful. So, talking about the partnership with Microsoft, so we feel very lucky, or I would say privileged, to work with such visionary partner on such project. And going back to what I said before, you know that the collaboration, putting all the scientists all together by Ernest Solvay 100 years ago, and collaborating today with other companies, that's the sense of science. So we are very happy and very excited about the next steps and the future. And let's see what we can discover next. I will now give the floor to Prashant. Thank you.
Thank you, Julie. My name is Prashant Varshney. I am John's peer, part of the discovery team, leading product management for silicon and physics as an industry vertical. Let me just pick up from where John touched upon earlier. Like, if you look at the iterative nature of the scientific method, this was talked about in the context of research, but very similar thing applies on the engineering side as well. So parameter optimization, fastest time to market, design space exploration, and being able to integrate the entire stack and be able to optimize for that. So you've got this knowledge base that is built upon product documentation, your own prior designs, specifications, best practices, et cetera. You use all of that to generate hypotheses and configure experimentations, configuring tools and infrastructure the right way, being able to run those experiments, typically in a large-scale HPC environment, and being able to then extract the results, analyze, and then be able to get into this iterative loop with the insights that are generated from each iteration. So this problem sort of remains the same across the engineering spectrum, right? So if you look at any modern day engineering application, they're hugely complex, and complexity is continuing to increase, starting from all the way from, let's say, a chip design to consumer product design to aerospace or automotive, et cetera. The complexity involved is huge. So for example, if you start in the chip design domain, you've got these billions of transistors that you have to now manage the collaboration across logic design, manufacturability. You have to look at the mechanical and electrical and chemical aspects of the chip. On a consumer device, you have to start thinking about how you're going to model the real physical effects into being able to do the design trade-offs. So you have to look at all the structural simulations, you have to look at the fluid dynamics, electromechanical, electromagnetic effects, and all have to be taken into account to be able to optimize the design and be able to do the trade-offs. We have a similar challenge in our own teams, our own Surface team as part of Microsoft, the consumer products team. They are constantly being challenged on how to optimize these designs with the trillions of parameters, with a trillion of different combinations, starting from the device level to the system level, where you have this multiple physical phenomena that are interacting, causing, necessitating, expanding the design scope and expanding the solution space as well to be able to optimize these designs. So this is the very problem that we are looking to solve with the combination of the solution that's offered by our partner, PhysicsX. So PhysicsX is offering a solution, an AI-based solution that is helping accelerate the design cycles and be able to iterate over hundreds of these design examples and be in days versus weeks. They've got this AI native workflow that combines the traditional machine learning techniques with the large language model capability to really be able to accelerate and be able to do this kind of design trade-offs in real time. And I'm going to show you some of that in the demo that's coming up. So we are working very closely with PhysicsX in trying to integrate their solution as part of discovery and be able to offer our customers the solution that can really help accelerate the design process. So just to give you an idea of the complexity that's involved in this design process, let's just consider the thermal design. And so the example I'm picking over here is a Surface laptop. And this is really hugely complex because not just it has multiple physics that has to be modeled, but you have to start looking at the design from end to end, starting from silicon selection to start to think about the physical form factors and also like all kinds of UX constraints that are put on the design as well, from skin temperature to acoustic limits to noise and exhaust air temperature, et cetera. So a lot of this stuff that starts at the component level simulation and then evolves into a system level simulation, which becomes a multivariable problem. Again, trillions of combinations in solution space. It's humanly impossible to be able to cover all of those. And therefore, by definition, you end up with a suboptimal design. So I've talked a lot about what can be done. So let me just show you how this actually works in practice. So I'm going to show you a demo. Our team set out to actually do a cooling fan design. This is the Surface team that took this initiative. Using the combination of the solution from PhysicsX and Discovery, a cooling fan design, which basically starts with some interaction between a user experience team and the engineering team, where the user experience team has gotten feedback on some early prototypes of the fan. That feedback, along with the specification and improvements, have been provided to Discovery platform, which analyzes the specification and then works with the PhysicsX agents to be able to produce new competitive designs. And so that goes through three steps. Start with the PhysicsX model for the fan itself, produce the concept designs, and then be able to select a few from that, and then be able to finalize the design and produce a detailed report. So that's what I'm going to be showing. So this interaction starts with, this is, as you can see, a chat between the two teams that's happening. The UX team is interacting with the design team. They're just saying, hey, we've got this feedback, this noise level is too high. We've got to do something about it, a new specification, and the feedback has been provided to the design team. And this obviously is a chat interaction and basically saying, okay, I need to take action on this design iteration. So they would just take the specification documents and the feedback that has come in as is and move over to the discovery interface. So you will see that happening now. That has been provided as an input to Microsoft Discovery. You just notice the prompt that has been given over here. So just look at these new requirements. I have my old design. You've got the new specifications as well. Just give me more combinations, 5,000 different cooling fan designs. It's analyzing that request and being able to now understand what is the plan that's needed for it to execute to be able to produce the designs, calls in the PhysicsX agents that you see over there and produces the optimized results. So then user then now clicks on the results, and now you can see there's like most of the results that are closest to the Pareto frontier have now been represented. Every triangle represents a design, a unique design. And so you can see this and look at the trade-offs between the noise and the flow rate. And based on that, you can start picking out the ones that are most interesting to you. With that, now you can compare this, and these geometries are now being generated in real time, and 4 of these designs are being compared just to see. You can see like minor differences in the fan designs. These are indeed different designs that are producing different trade-offs between the parameters of interest. At this point, if it is not interesting enough, you go back. Again, interacting in natural language, you can produce more number of designs, vary your constraints, and be able to then produce the outcomes. Now, once that you know that this is a design you are going with, then you go back to the discovery interface, and you say, okay, these are the designs of interest. These are the parameters I would like to now finally simulate for. And this goes to produce the final report. And this final report now does the real-life simulation for these design parameters, and then produces the final outcome, which is the final report that gives you the real-world simulation for these fan designs. So with that, then you basically conclude your fan design process. So you see how we started with a very, very broad solution space, also starting from natural language, basically saying, this is the problem that we want to solve. Feedback directly is along with the specification provided, explore through a bunch of different design options, and be able to converge to a specific design in a matter of minutes, right? This is really the power of AI. And so this has been accomplished by our Surface Thermal team. So here, I'm just going to play a short video, and let's hear directly from them.
Hi, my name is Pritul. I lead a part of product development and engineering system team in Surface for last 10+ years. Surface is where Microsoft brings the powerful performance with such iconic design. We have to work towards the best solutions and design, working through many iterations to ensure that our users have the best experience with our products.
AI and simulation enables us to evaluate a vast array of design possibilities much more quickly and thoroughly than before. Instead of spending weeks or months on a handful of concepts, we can now assess thousands in minutes or even seconds.
This is a typical surface cooling fan. The 𝗦𝗽𝗲 has 18 parameters. If we just have a few design options for each parameter, it can quickly end up with thousands, even millions combinations. But with AI, we can study all the options and find out the optimal one, which have highest airflow and the lowest acoustic. If we give AI a design space, it could come up some designs that a human never imagined before.
We have such a talented team in Microsoft Surface. And now with AI models on Microsoft Discovery, we have revolutionized what we can achieve for our users together.
Cool. This stuff we find really, really cool. And again, a shout out to the Surface Thermal team. I know the teams online, also the PhysicsX team, they may be watching online. And thank you, Pritul. He's actually joining in person with us right here. So appreciate all the support and partnership over here. So this is really the power of the system, right? Like being able to start with a broad set of combination, do quick iterations, and then be able to actually impact your product design cycles and shrink it from months to weeks. This is truly the power of the solution. So what you really saw from the Surface team, you heard, like can really have a real world impact, not just accelerating the design convergence, getting faster to market, but also really pushing the boundary on innovation, really being able to explore solutions that are beyond human intuition. And then, of course, the extensibility, like beyond the Surface products, we're looking at other consumer products like Xbox and all, but then more importantly, expanding into physical systems like data centers. They can also benefit from techniques like this. I'm going to close with this. I just mentioned, the design sort of beyond intuition, right? Outcomes that are actually beyond human intuition. So our Surface Thermal team actually took this initiative. In addition to the fan that was designed earlier, they also set out to design a new passive heat sink. There's no fan involved over here. It's a passive heat sink, right? So this is a design that you see that human has done. And they gave this task to AI, to generative AI, to produce a brand new design with a certain specification, with a certain thermal dissipation target for a specific product. And this is the design that AI came up with. So the cool thing about this is, this still, by the way, gives me goosebumps every time I see this picture. But the cool thing is, not only that this design is functional, and I've got it right here, by the way, just for you all to see. Not only is this actually functional, this actually produces 25% better heat dissipation compared to the human design. So this is really awesome, and we find really cool applications. Just imagine if this is possible today, what tomorrow can bring, right? So this beyond human intuition, it is just not a tagline anymore. It is the new baseline. With that, I'll pass it back to John.
I'll just stay up there. Thank you, Prashant. Thank you, Julie. And I'm glad that I don't have the monopoly on cool jokes when it comes to thermal solutions, so I appreciate that. I hope today you saw the power of what we're doing. Like things like this, it's real outcomes. It's real solutions. We've seen that along the journey. It was important to us to prove that we could actually do something with these tools, and we've been so excited about what we've been able to achieve. And I hope you've seen here across domains, whether it is core research, design, engineering, the world of chemistry, material science, our partners, like we showed the in silico solutions for pharma. We've got a broad suite of partners across all of these domains working with us today in private preview. Stay tuned very soon. We'll be sharing even more about that journey as we go forward. If you're interested in joining us and seeing what these tools can do, you can go there to aka.ms/Microsoft Discovery to engage or reach out to your Microsoft account teams. We're so excited for the future and what it can bring. We think bringing these technologies together to provide this kind of platform can really help solve some of the world's greatest challenges, and we want to put these tools in users' hands. We have probably just about 2 minutes left today, so we could take a question or two, but we will also be available over in the Microsoft area of the hub this afternoon. Feel free to chase us down over there between 11 and noon, and we'd be glad to answer any other questions you have. But again, thank you very much for your time today. We appreciate it. Thank you, Prashant. Thank you, Julie.
Thank you very much.